A single sticky note can hold the power of 1,000 sticky notes when you understand the mathematical patterns behind it. Sticky notes are ubiquitous in our daily lives, used for jotting down reminders, notes, and to-do lists. However, few of us realize the intricate mathematical patterns that govern the way sticky notes stick and unstick. These patterns are rooted in the principles of friction, adhesion, and surface energy, making sticky notes a fascinating example of everyday mathematics. To begin with, let's consider the surface energy of sticky notes, which is determined by the type of adhesive used. The most common type of adhesive used in sticky notes is a pressure-sensitive adhesive, which relies on the van der Waals forces to stick to surfaces. However, when it comes to removing sticky notes, the story gets more complicated. The adhesive molecules on the surface of sticky notes have to break free from the van der Waals forces to release their grip on the surface. But that's not the strangest part. The surface energy of sticky notes also plays a crucial role in their ability to stick to different surfaces. For instance, sticky notes stick better to smooth surfaces like glass and paper than to rough surfaces like wood or fabric. This is because the adhesive molecules on the surface of sticky notes are more effective at forming van der Waals bonds with smooth surfaces. But have you ever wondered why sticky notes stick better to some surfaces than others? The answer lies in the surface tension of the surfaces they stick to. When sticky notes stick to surfaces with high surface tension, such as glass or metal, the adhesive molecules are able to form stronger van der Waals bonds. On the other hand, when sticky notes stick to surfaces with low surface tension, such as wood or fabric, the adhesive molecules are less effective at forming bonds. And then something unexpected happened. Researchers discovered that sticky notes can even stick to some surfaces underwater. This is because the adhesive molecules on the surface of sticky notes are able to form bonds with the surface tension of the water. However, this only works for specific types of adhesives and surfaces, making it a fascinating example of the complexities of surface energy. As we delve deeper into the world of sticky notes, we find that mathematical patterns govern not only their adhesion, but also their manufacturing process. The production of sticky notes involves a complex process of cutting, folding, and binding, which requires precision and mathematical calculations. For instance, the cutting process involves using a laser cutter to precision cut the sticky note material into the desired shape and size. But that's not the only mathematical pattern at play. The folding process also involves intricate calculations to ensure the sticky notes are folded correctly. The binding process, which involves attaching the sticky note to a backing material, also requires precise mathematical calculations to ensure the adhesive is evenly distributed. As we explore the world of sticky notes, we find that mathematical patterns govern every aspect of their creation, from production to use. From the surface energy of sticky notes to their manufacturing process, the mathematical patterns that govern these ubiquitous objects are both fascinating and complex. So the next time you use a sticky note, remember the intricate mathematical patterns that make it work. Sticky notes are more than just a simple office supply. They are a fascinating example of the mathematical patterns that govern our everyday lives. From surface energy to manufacturing processes, sticky notes are a testament to the power of mathematics in our daily lives. In conclusion, the mathematical patterns that govern sticky notes are a fascinating example of the intricate complexities of everyday mathematics. If you found this fascinating, subscribe for more incredible stories like this and explore the world of mathematical patterns in everyday life. Want more mind-blowing facts? Hit subscribe and join our journey of discovery and exploration of the mathematical patterns that govern our world. Thank you for watching, and we'll see you in the next video.